Hi, so in this video we're going to look at integration by parts again, but we're going to look at two special cases, okay? So hopefully what you can see from the first case, there's not two functions there, okay? But I still haven't shown you how to integrate log x, so what we're doing is I'm telling you to integrate it by parts, and if you're only given one function, what we do is we create a second function in the form of 1 times log x dx. And now we're going to do something counterintuitive to what I've maybe been telling you in the past, is that we're choosing the one to differentiate, which is actually going to make it look originally more complicated, but because of this log x, it will all be fine. So let f of x equal log x. That means f dashed x is going to equal 1 over x, which means that g dashed x is 1, which means that g of x equals x. Okay, so that means we've got the integral of log x dx will equal f of x g of x minus the integral of f dashed x g of x. So we get the integral of log x dx equals x log x minus the integral of 1, because the x's cancel out, and you can see why that works out that way, and that's why doing it in this opposite way has worked out. So log x dx will equal x log x minus x plus c. So the integral of log x equals x bracket log x minus 1 plus c. So if you're told to integrate by parts and only one function, just make it 1 times that function. And then you've got two functions. Okay? So we'll do one more special case. So here we've got two trigonometric functions. So it may seem at first like, how are you going to decide which one to differentiate, which one to integrate, because it doesn't look like it's going to make any difference. And well, other than dealing with fractions, you're correct, it's not going to make any difference. So looking ahead, which one do we want to differentiate? If I differentiate sine x, I'm going to get cos x. If I differentiate cos 3x, I'm going to get negative 3 sine 3x. So that doesn't seem like there's much difference, but say if I integrate cos 3x, I'm going to start dealing with fractions, and if I integrate sine x, I'm not. So I'm going to differentiate the cos 3x, which means that f dashed x equals negative 3 sine 3x, which means that g dashed x equals sine x, which means that g of x equals negative cos x. Okay, so we're going to get the integral of sine x cos 3x dx equals f of x g of x. So we get negative cos 3x dot cos x minus the integral of f dashed x g of x. Okay, dx. Now let's simplify that. So we get negative cos 3x dot cos x. Let's take out the negative, and the 3. So those two negatives are going to cancel out. Take the 3 out, so we get negative 3 integral of sine 3x cos x. So now we need to integrate this. And if you're looking at this and thinking, but how are we going to end up with a solution? Because surely no matter what we do, we're just going to keep cyclically returning to two trigonometric functions, and you would do that, but something is going to happen which will mean we'll be able to fix that. So let's do a second iteration of integration by parts. I'm going to make f of x sine 3x, which means that f dashed x is going to be 3 cos 3x, which means that g dashed x will be cos x, which means that g of x will be sine x. So we're going to get the integral of sine x cos 3x dx equals negative cos 3x cos x minus 3 brackets f of x times g of x, so sine 3x dot sine x minus the integral of f dashed x g of x. So we get the integral of sine x cos 3x dx equals negative cos 3x cos x. So let's break out this bracket. So we get negative 3 sine 3x sine x. Negative 3 times that negative will become positive, and let's also bring that 3 out, so it's going to be plus 9 times the integral of cos 3x sine x. Okay, so what are we going to do now? Because like I said, we're going to keep repeating and then we're never going to get a solution. Okay, what you should hopefully notice, we have 9 times the integral of cos 3x sine x, and we also on this side have the integral of sine x cos 3x. They're written the wrong way around from each other, but they are the same. Sine x times cos 3x is the same as cos 3x times sine x. So what I'm going to do is I'm going to take this over to the left hand side. So we get the integral of sine x cos 3x minus 9 times the integral, and just for neatness I'll rearrange them, and the sine x cos 3x will equal negative cos 3x cos x minus 3 sine 3x sine x. There's one of them, take away 9 of them, so it becomes negative 8 sine x cos 3x cos 3x cos x minus 3 sine 3x sine x. And how do we get this on its own? Divide through by negative 8. So the integral of sine x cos 3x will equal 1/8. Negatives will cancel out. Cos 3x cos x, negatives will cancel out, plus 3/8 sine 3x sine x plus c. And that's how you would integrate a function of that type using integration by parts.